Hey kids, this is Mr. Bunt coming to you live for another math lesson. And this will be the final math lesson that I will post for the next week, because next week was supposed to be our spring break. So I will just take it easy on you just a little bit for about a week. And my next math lesson after this one won't be submitted to my YouTube channel and Google Classroom until April 13th. So you'll get a week off next week for math lessons, but I will be posting other things for you to do. I'll continue to post Harry Potter and some cool science videos that I find, but math we'll put on hold for about a week. So here's our math lesson for today. It is lesson 13, and the objective is I can multiply mixed number factors and relate to the distributive property and the area model. We are going to find the area of a rectangle today using the area model and also going back to multiplying fractions. And the area model was really just a way to show you what is going on with the numbers. How are we actually solving for the space that's inside a rectangle? So, I mean, that's really what the area model was showing you, breaking apart those lengths and widths to actually show you how the multiplication is working when we find the total area of inside this two-dimensional figure. So I'm going to be doing two separate strategies today. I'm going to give you two different problems as examples for you to look at while you do your problem set, in case you need some guidance there. And then once I'm done with the two examples, I'm going to go through your problem set that I'd like you to do after this math video and just take it, problem by problem, and just see if I feel like there's anything I need to add onto that. All right, so for our first problem, we have a rectangle here, and we're going to do the area model first. And I'm going to show that the length of this rectangle is 1 1/3 inches. And the width is going to be 3 3/4 inches. Now, recall I moved them further away from the actual side because I'm going to break those numbers apart. So for this mixed number, I'm going to break apart 1 1/3. So 1 is much bigger than 1/3, so I'll put 1 there. That's 1 inch from here to here. And from here to here, that's only going to be 1/3 of an inch. Over here we have 3 as a whole number, and then we have 3/4. So this will be 3 inches from here to here for the width. And from here to here, that's going to be 3/4 inches. Now for the area model, now we simply multiply where the numbers meet up. So 3 will walk into the center of this smaller rectangle, and it'll meet up with this 1. 3 times 1 is 3, so that's 3 inches. And remember, we're dealing with area. There's two dimensions here, length and width. So we're going to make sure we put a tiny baby 2 there for our area, so that's 3 inches squared for this rectangle. 3 times 1/3, I'll just write over here to help me, will be 3 times 1 is 3. 3/3 is also equal to 1. So that'll be 1 inch squared, right? And then we're going to move down here. 1 times 3/4 for this rectangle. 1 times 3/4 is simply 1 times 3. Denominator stays the same. That'll be 3/4 inches squared. And then finally, we're going to have to multiply two fractions. So we have 3/4 times 1/3 for the area of this smaller rectangle. So recall, when you multiply fractions, you just go straight across. 3 times 1 is 3. 4 times 3 is 12. 3/12, all right, is our area for that smaller rectangle. Now, when it comes to simplifying fractions, you don't need to do it just yet, but if you do notice that we have another fraction that's already in fourths, and we know that 12 is actually a multiple of 4. If we skip counted by 4s, we would end up getting to 12. So in this case, you can simplify this fraction here. So divide what by 12 to get 4? Well, you divide it by 3. And then you can divide the same number 3 by the numerator up here, so 3 divided by 3 is 1. So you also have a fourth. So you can go ahead and basically call this 1/4 of an inch. And I'll just write it down here. I don't have enough room. 1/4 of an inch squared. Now our job is to add up all our areas in order to get our total area of the entire rectangle. So I'm going to start with the whole numbers here. 3 plus 1, I'm going left to right, plus 3/4, and then plus a fourth. 3 plus 1 is 4. 3 plus 1 here, 3/4 plus 1/4, so we get 4/4, so that's 4 and a fourth. This is read as 4 plus another 1. Our answer is 5, and we're in inches, and we're looking for the entire area, inches squared. So that's if we were saying we were doing 1 1/3 times 3 3/4. We would get an answer of 5 inches squared for the area. I'm going to show you another strategy in order to solve this type of problem here in a second. Let me get my eraser. I forgot to bring it over to my counter here. All right, I got it. Now, same problem. We're just going to do it a little bit differently. We're not going to use the area model, and this might be a preferred method for you. We've done plenty of math this year where it depends on the strategy that you want to do. So we have a length of 1 1/3. We have a width of 3 3/4. And it's going to be in inches again. So in order to solve this type of problem, you would change these to improper fractions, multiply across, and then in the end, if you need to use the long division algorithm, you'll have to use it. So here's the trick. 3 times 1 is 3, plus the 1 is 4. Denominator stays the same. Multiply. 4 times 3 is 12, plus 3 is 15. The denominator stays the same. Now you'll multiply straight across. Let's do the easy one first. 3 times 4 is 12. 4 times 15, I don't know. Let's look over here. 15 times 4, 20. 4 times 1 plus 2 is 6. So you get 60. Now, you have 60/12. Your answer needs to be a whole number or a mixed number. 12 goes into 60 how many times? Well, you should know it's 5, but if you need to do the long division method, make sure that your numerator, remember, is going to be your dividend. It's going to be inside your division bar here. And then your denominator is going to be your divisor. So this is how you would set it up. 12 goes into 60 how many times? It doesn't go into 6, it goes into 60. It goes in just 5 times. Our answer, once again, just like we got with the area model, 5 inches squared, because we're dealing with 2 dimensions. That is how you would go about that problem, using the area model and also using the strategy of changing your mixed numbers into improper fractions, multiplying across, and then using long division, like so. Let's try one more problem here, and then I'll talk about your problem set. Okay, I'm showing both the area model again, and I'm going to show the standard algorithm with changing the fractions to improper fractions. Let's try a rectangle that is, oh no, my purple marker is getting a little dry. 16 inches. Let's see here. Okay, 16 inches. Okay, 16.5 inches is our length. So we're going to break apart our length, 16, and we have a half. Remember, these are inches. Here to here, 16. Here to here, half of an inch. And let's see that our width is going to be 4 1/4 inches. We're going to start with the area model here. Break this apart. So 4 from here to here, and then we have 1/4 of an inch from there to there. Area model, find the partial product. 16 times 4 will get us the area there. So we got to go over there and solve the standard algorithm to get 6. So you have 64 inches squared for the area of this smaller rectangle. 4 times a half, or half of 4, that's a nice easy one with mental math, 2 inches squared. 16 times 1/4, you would end up getting 16/4. 4 goes into 16 4 times. 4 times 4 is 16. So 4 inches squared. And then finally a half times a fourth. So 1/2 times a fourth is 1/8. So the area of that small rectangle is going to be only 1/8 of an inch, and that's going to be squared. So it's a lot tinier of a rectangle. Now, our job is to add them all up. Here we go. 64 plus 2 plus 4 plus 1/8. Now, recall, because we have a fraction in our addition expression here, that's why I'm writing it left to right. If I wrote it up and down vertically, you'd have to change this to a decimal, and we're not going to do that right now. So we're just going to write them left to right, and we're going to add the whole numbers first, and then if we have to add fractions, we'll do that in a moment. So here we go. 64 plus 2 is 66, plus the 4, plus the 1/8. I'll just rewrite it. 66 plus 4 is 70, plus the 1/8. I end up with the answer of 70 and 1/8 inches squared. So 16.5 times 4 1/4 will get me an area, length times width, of 70 and 1/8 inches squared. So if we had little tiny squares inside the entire big rectangle here, there'd be 70, and there'd actually be a fraction of one more. So that'd be 70 and 1/8 of these cubes, or sorry, not cubes, but just little squares inside that big rectangle. All right, now let's try the other strategy. We're going to get the same answer of 70 and 1/8. Here we go. I'm going to write it. I'm going to leave the answer just to show you that we will end up arriving there. So we're going to have 16.5 times, let's see here, 4 1/4. Change to improper fractions. 2 times 16. Some of you could probably do that mentally in your head, but just to be on the safe side, solve the standard algorithm. You get 32 plus the 1, 33. Denominator stays the same. Halves. Multiplied. 4 times 4 is 16, plus the 1 is 17. Denominator stays the same. You get a 4. Now you're going to multiply straight across. 2 times 4 is 8. 33 times 17 is where we have to do a 2-digit by 2-digit multiplication problem, and that's when we have to drop the egg. So you can already see here that the denominators match up, 8 and 8, so that's pretty good. So 33 times 17. All right, so here's our snake, the snake of Slytherin, Salazar Slytherin. All right, 3 times 7 is 21. 7 times 3 is 21, plus 2 is 23. Drop the egg. Snakes lay eggs. 1 times 3 is 3. 1 times 3 is 3. Add them up. 1, 6, 5. 561 eighths. Now we got to do long division. We will get this answer in the end. I hope so. Let's find out. So 561 divided by 8. Remember, this is the second strategy to solving that problem. So if you like the area model better, if you feel it's easier, go ahead. If you think this strategy is easier, go ahead. Definitely. Does 8 go into 5? No. Does 8 go into 56? Yes. How many times? 7. Goes right above this 6. Becomes 56. Subtract 0. Bring down your 1. We still have a space up here, so we're going to have to do the whole process again. Bring it on back. 8 goes into 1 0 times. 0 times 8 is 0. 1 left over. No more spaces up above in our quotient. This is now our remainder. This is also going to be our numerator, and this is going to be denominator. Right? So and that's our quotient, that's our whole number. So it's 70 and 1/8. And of course, we were in inches from the get-go. Squared, 2 dimensions, length and width. And you can see that we got the exact same answer for both the area model, and then this strategy, you can just call it the standard algorithm model, SA. Whatever one you want to choose, pick the best one that serves you. We all think differently, we all learn differently, so whatever's the best one suited for you. Now let me quickly go over the problem set that you will have. It's lesson 13 in your workbook, and you are going to do, let's see, I'm going to write it down first on my whiteboard. Lesson 13 problem set. And today you're going to do pages, looks like there's only 2 of them. There we go. Pages 184 and 185. This is your lesson for your homework I'd like you to do after the math video. And once you're done with that, go on Prodigy. Have some fun on Prodigy today and go on Sumdog. So for some relaxing fun over the weekend. All right, so let's go over this problem set. Now I'm looking at number 1. It says find the area of the following rectangles. Draw an area model if it helps you. So for these 4 problems, you're not going to have a ton of room, so once again, grab a scrap piece of paper, solve these problems on there. You can choose to, for the first one, if you want to draw a rectangle, make this the width, make this the length. You totally can. Here's the issue though. If you do the area model, you're going to have to change this 12/5 into a mixed number, where it's a whole number and a fraction. That way you can break apart that rectangle to find the partial products. If you just want to simply multiply across, use long division in the end, go ahead. Make sure you're following the units as well with these problems. So you have those 4 problems there to solve. Down here, number 2, Julie is cutting rectangles out of fabric to make a quilt. If the rectangles are 2 3/5 inches wide and 3 2/3 inches long, what is the area of 4 such rectangles? So I'm going to give you a big hint. What you need to do here is you need to find the area of just one rectangle. You have your width, you have your length. Multiply these 2 numbers together, and then once you get that, then multiply it by the number 4. So you're going to get an answer, and then it wants you to find the area of 4 of those rectangles, so just multiply that by 4. And finally, number 3. Mr. Howard's pool is connected to his pool house by a sidewalk as shown. He wants to buy sod for the lawn shown in gray. How much sod does he need to buy? When you think of sod, think of dirt that you lay down in your front yard and then you put some nice grass over it. So he wants to have a nice front yard here, and Mr. Howard. I had a Mr. Howard in 3rd grade. That is so cool. I think about my old teachers all the time, but Mr. Howard, I'll just pretend it was my former 3rd grade teacher. So here's what you need to do. In order to find the area of the gray, first solve the area of the entire large rectangle. 24.5 times 24.5. Once you do that, you have one of your numbers that you need. Then you're going to have to solve the area of these 3 mini rectangles. You can see here, this small one right here is 1 times 3. The area is going to be 3 yards squared. Here, you have a pool also that it has an area of 16 yards squared, which means you got to figure out what the side lengths are. And I will give you one big hint. This is actually a square. So what does that mean about the side lengths? And then for this one here, this is 7.5 by 2.5. So multiply these 2 numbers, you will get the area of the pool. From there, you need to add up the area of the pool the area of the pool house, which you already have, so technically you don't even need to find the length and the width of this because they already gave you the area. So silly me on that one. You just go ahead and this is already done for you. So find the area of this one, add them up, all three, and then you'll subtract that number from the area of the entire big rectangle, which is considered the lawn. And then your answer will be it will actually end up being the gray that is shown here in your picture. I believe that I'd like to go over this problem. So the more I look at it, I think I might actually do this problem in a separate video and send the video out to you tomorrow. I am considering that. So I'm gonna do that because this is a challenging problem that takes a lot of work, but I want you to try it. So if you don't see my math lesson video and you already see that I've posted the answer to this problem, wait. Don't watch the answer video yet. You want to try it on your own. That's how we learn. So I think I'm going to do that. So expect one more math lesson video tomorrow. All right, kiddos. That's your problem set. You got numbers 1, which includes 4 area problems. You have your number 2, which is your quilt. And then you have number 3 with Mr. Howard and his pool house, and the area surrounding it. Those 3 problems, and once again, you can see it's kind of erased there a little bit. Page 184, page 185. When you're done, Prodigy and Sumdog. But of course, even before that, watch my second math video on lesson 13. I will post one more video showing you the answer to number 3. Good luck, and I hope this was a good math video for you kids to watch. It went a little bit longer than usual, but that's okay. All right, this is Mr. Bunt signing off, and once again, one more math video tomorrow going over number 3, but after that, kids, I'm going to give you a week off from math, and we're going to honor our regular spring break, and then we'll get back into math on April 13th, which is a Monday. Have a great rest of your day, kids, and I'll see you soon.